ridiculous thing I made. Um, at the highest level, we have a web app, and this is what it looks like. It's called Loss a Lot because that's a play on losing a lot of quality. This is about doing spectral and binary analysis of a given media file and then basically being able to see, hey, was this one time down converted and then it was put back up to 320 kilobytes a second, but it's really not. So that's like the thing we actually want to do. Um, we can try that here in the browser. And so this is like the final product we've kind of gotten to, right? So here's a Charlie Miller tape from the Grateful Dead. It's pretty good quality, but it's lossy sounding audio because it's an audience tape. But we can see here that it's actually real lossless because it doesn't have the fall offs that something actually lossy would. It's just a fact of the medium. Now we can go and do another file. This bomb band, they're very noisy. And so this falls into suspect. And we see some low cuffs. And we think that it's a FLAC and it was originally lossless. So we don't think that it had a crazy pass. This actually probably looks good. And that's exactly what we want. We just made some changes that do that. Now, about making those changes, this actually originally is a Rust program. So if we just do nice little cargo build here, we can go target, release, and then ocelot, and then just pass it GUI, and we pick a folder, right? So we'll go fiddlesticks. Let me code. I have like a bunch of files in here, so I'm just gonna do it in this whole directory. Boom, we see like this CSV come out. We've got all this, and this is like our main report, and we can also like go and look on the web. Oh, is it 3002 or something? Oops. No. Okay, I messed something up there. Anyway, so this is the CLI. Like, it's perfectly passable. It does stuff. It's whatever. And so, like I took this pure Rust CLI that I built with Claude, and I turned it into this pile of WASM, which was like pretty cool. But I decided to go way further with it. So I made a bunch of like assistive tooling for Claude to build this. So if we go to the quick start page, we can kind of actually see like what's all over here. The decision graph, Claude tooling, and story. We can start with all this. So like this goes through just like the timeline of everything I've made. It's not worth hitting right now, but you can see that it's like kind of wildly expanded. It's interesting. The main big piece of this is the Claude tooling. So we have a complete decision graph that is a literal directed acyclic graph, and it stores every single thing, every single choice, action, whatever that is made by the robot, and keeps it in this database grouped in pieces of work that are just edges and nodes or whatever, right? And so we can now query out what we were doing and bring this in anytime a compact happens, whatever, or at the start of a session. And Claude has like some really specific instructions here and some helper tools that it can just use for this project specifically. Beyond that, it also keeps all of its Git operations logged. It makes backups of everything, so it can't do anything destructive. It also has a bunch of rules about how it commits in the flow. It won't let anything happen if the tests aren't passing and the code isn't compiling. It's very strict. And then this all gets built up into like a real living system, which of course we can just go and look at. Now, the decision graph, like this is the highest level of it. We have goal, decision, option, action, outcome, and observation. These are the things that we really look at. These are scored with confidence weights. When we have confidence weights, these all now can lead to chosen, rejected, requires, blocks, or enables. And like we can look at a real problem here, like this lo-fi thing that I ran through with Charlie. We got two approaches, temporal cutoff variance and cross-frequency coherence, and we had it go out and do these experiments to ultimately come to this and realize like this is the call to make. Now, this was great and it all worked out really well, And it looks kind of abstract right now. But what we can do is actually go and see the decision graph of everything that's happened here. So like here's what we were doing when we made GitHub pages get fixed up. We had a goal of fixing the pages. We made the decision of like, okay, we're don't see the site working. Jekyll build is fucked up. Oh, the demo page has no data. Fix a JSON path. Div wrappers and markdown parsing, do something. Observation, do something. Decision, workflow, queuing up on rapid pushes. Cancel in progress. Now the page's site is working. The landing and demo and WASM outline are there, and it adds the decision graph to the memory workflow here. So like these are all real sequences of events that have just happened as I've been making this, and we can browse all of them in this way. Now we can also even go so far as to see a real directed acyclic graph here. We can dive through all of this, and you've got every type of action that's here, and like all of the information about what happened with each of these, and you can go through the whole decision process from and to all of it for any of these throughout your whole development life cycle. Obviously, you could like need some better browser stuff for this, but it's pretty crazy. Now, how do we use all of this? Um, it's just really impressive with how quickly it's allowed me to build this out. Like if we go and we actually look at this code base, it's pretty impressive. I've spent 8 hours building this, and if we look at it, we have like what are our stats? Yeah, I don't want to filter by. I want to go like where's my stats page? Insights. Yeah, let's like just look at this contributor graph real quick. It's gonna be crazy, just dense. So yeah, like 30,000 lines of code minus 6,000 plus Claude's 2,000. So like 32,000 plus 32,000 minus 6,000 in 8 hours to build something that is this completely self-contained web page, a full analysis binary that's as good at doing this as a real sound engineer and is passing every test. And we've been able to like work through all of this pretty reasonably. Now I have it working on making a new page with a decision graphs that's a new explorer that we can see right here. This is really about like adding a new chronological explorer with more context going to GitHub and seeing our decision trees as we like make multiple decisions. And it's adding confidence weights here as it adds more spikes so that we're going to see something kind of real coming up. And so, like, this is kind of still chugging along, but we can go look at Spike A's PR here as this is working just within all of our rules. And this new Splunk page, like, does some stuff. And, I mean, in reality, like, let's merge this and just see. How much confidence do we have, right? Like, we're going to be able to see if this was good or bad, and I'm just merging it in. And we'll tell it, like, you might have to fix this. So we'll let that happen. And yeah, this is just like a whole new Splunk page. So like we'll see this kind of go up. We're gonna look at the GitHub pages build, and here it is. This is so ugly. I need to fix this. But yeah. So we'll go to Smash Splunk and see if it's here. Yeah. Okay. So like now we can see how everything was made here. And so like we're still seeing some issues. But like this, okay, so undefined percent. I got a few bugs here. But like we can look at all of these actions leading to code, go to full diffs. Like all of this is stuff the robot could extrapolate running its own page locally and be able to use this to help make decisions, which is just pretty dope. Um, like chasing this whole chain, like it needs some better organization, but it's really powerful. And you know you can break this down in different ways. We can go to linked only, and like the I don't know, this is just like really something